So let's make a start with looking at the first group of questions. So looking here, first question, find dy dx of the following. So obviously 2x squared plus 3x minus 6. Dy dx of this quickly becomes, well, 2 comes down, so that's 4x plus 3, nice and easy. Then the next one we have to expand, so x minus 3, x plus 2, x minus 1. What does that expand out to? So first things first, we just look at these two here. So that x squared plus 2x minus 3x minus 6. X minus 1 on the end there. So that's x squared plus 2x minus 3x. So that's x squared minus x minus 6. And then from there, well, we don't need that plus there, do we? From there, we now need to expand again. So that's x squared times x, which is x cubed minus x times x is minus x squared, yeah. And then we need to do minus x times x, which is plus x, so that's x squared times x is x cubed, x squared times minus 1 is minus x squared, minus x times x is, minus x squared again, minus x times plus minus 1 is plus 1, minus 6x times x is minus 6x, and then minus 6 times minus 1 is plus 6. This all evens out nice and neatly down to x cubed minus x squared minus x squared is minus 2x squared. Minus x, that's plus x in there. Minus x minus 6x. So plus x minus 6x is minus 5x, and then plus 6 on the end. Now that we have that, we can then do dy dx. Which is going to be 3x squared minus 4x minus 5. So that will be for that one there. And then C, nice and easy, it's 4x cubed minus 2x squared minus 9x minus 12. Well, that's 12x squared minus 4x plus 9. D, this is a negative indice, so what we need to do is we need to go, well, take the minus 1 down, so it's going to be minus 1 x to the minus 2, but because I said using only positive indices, what does x to the minus 2 become? What does x to the minus 2 actually become when I turn it into a positive? First of all, how is x to the minus 1 supposed to appear? Yeah, 1 on x. So what about x to the minus 2? What's that supposed to look like? Yeah. So the whole thing, once you put it all together, so x to the minus 2 is supposed to be 1 on x squared. Then I put the minus 1 on top, so I have my correct answer. So, and then y equals the square root of x. What is square root in index form? That is the question. What is the square root of x when you write it in index form? All right, someone's got it there. X to the half, which is correct. So, square root of x becomes x to the half. Then we can simply follow along with what we've been doing this entire time. We take the power, put it down the front, and then we subtract 1 from the power. So what's half minus 1? What is a half minus 1? Yeah. All right. So, I'm not done because I said you express using only positive indices. So, we need to figure out what to do from here. So, first things first, we've got the half. We'll put the half over here, that's fine. Now, this x to the negative a half, though, is going to be what we have to work our way through. Think about it like this. This is x to the negative 1 times a half, which is the same as x to the negative 1 to the half. Now, we independently know what x to the 1 is supposed to look like. What does x to the negative 1 look like? Hint, it's up over here. Anything involving a negative power means you're supposed to flip it, which means that this will become 1 on x to the half. So we've flipped it. But then we also know what this is supposed to be if we were writing in index form. This is supposed to be that up there. So at the end of it all, what we end up with is a half times 1 on the square root of x, which means that it's 1 on 2 root x. Now, am I allowed to leave my answer like this? What do you guys remember about working with square roots? What do you guys remember about working with square roots in fractions? Now, you don't flip them, but I need to do something else to them. I can't end with a square root on the bottom of my fraction. So I need to do something to it. I need to rationalize it. So the question is, how do I rationalize it? How do I rationalize this denominator so that I can present it nice and neatly? Multiply. You don't need to multiply by the entire denominator by the entire denominator, because all that's going to do is cause a bunch of stuff to cancel out at the end anyway. But we just need to worry about the irrational part of it. So what I'll do here is I'll take my 1 on 2 root x and then times the top and bottom by root x. So then I have root x over, and what is root x times root x? Well, it's just x. And now I now have my answer in a rationalized, clean, positive indices only form. So for E, your answer should be, what's there? If you give it to me to this point here, depending on how generous we were feeling, we would probably give this to you still. It is still correct. It is just not the most correct way of expressing it. All right. So picture the following. Find when dy dx is equal to 0. Then find the turning and inflection points. So I'm going to just quickly make it. There we go. Make it nice and neat so it fits in the one thing and doesn't get blocked by my bloody thing. So clean board. Now, we've already found out some of these dy dx's. So for y equals 2x squared plus 3x minus 6, we know that dy dx is equal to 4x plus 3. When dy dx equals 0, for x plus 3, find x when dy dx is 0. We need to subtract 3 from both sides and then divide. So it's x equals negative 3 over 4. Now from this we then need to find the turning or inflection point. And that is on the original equation. So I now need to take this and go back up there. I need to take what I've got here and send it back up here. So I now need to do 2 bracket -3/4 squared plus 3 -3/4 minus 6. You can use your CAS to help you with this. I'm not that much of a monster. Except I'm going to do it by hand anyway, just because I can. So -3/4 squared is going to be 9/16, because when you square a fraction, you square the top. No, -3 times -3 is a positive. And then 4 plus -9/4 minus 6. What I now need to do is I need to finish expanding this, so that's going to turn into two lots of that. So that's going to be 2 times 9. Which is 18. So now I have 18/16 plus -9/4 minus 6. I now need to resolve all of this down. And remember, I'm finding y. So first things first, we can simplify this down. Half it turns it into 9/8. And because this one is now the easiest one to work with, 9/8, we can now turn all these other ones into amounts of 8. So 9/4 is actually going to be 18/8. And then this 6 will therefore just have to be 48/8. So 9 minus 18 minus 48 all over 8. So 9 minus 18 is minus 9. Minus 9 minus 48 is minus 57 over 8. That means the turning point for A so when y equals that, the turning point will be at -3/4, comma, -57 over 8. All right, so that's the full working out to find the exact location of the turning point. No CAS needed. Hopefully you do not need your CAS to do that one. The other ones, I'll be a little more flexible with on needing CAS. Probably because partly I need to use my CAS for this. All right. But before I can start breaking out my CAS, I have to show that I understand, or I can explain what it is I am trying to do on my CAS. So, just quickly going back, we need to borrow that from earlier. So so this is for B. This is taking into account the fact that A, B, and C in both the first two are the same. So this is B. We now need to find when dy dx is. So 0 equals 3x squared minus 4x minus 5. This is a quadratic and it's equal to 0. What formula can I now use? I have a quadratic that is equal to 0 and I need to find x. What formula can I now use? Thank you. So, because I have this, I can now do x equals negative b plus minus the square root of the discriminant over 2a. And my discriminant is b squared minus 4ac. So let's get this discriminant out of the way first. So that's negative 4 squared minus 4 times 3 times minus 5. So my discriminant is going to be equal to 16 plus 4 times minus 5 is plus 20 times 3. So my discriminant is actually going to be 76. That means that x is going to be equal to, so negative b, so that's plus 4, plus minus the square root of 76, all divided by 2a. A is 3, so that's all divided by 6. Now we can simplify this down a little bit. We are going to have 4 over 6 plus minus 76 over 6. 4 over 6 cancels down to 2 over 3. And then root 76 happens to be root 4 times root 19. And root 4 happens to be what? Square root of 4. Square root of 4, guys. Wakey, wakey. Thank you. So that's 2 root 19 over 6. 2 over 6, well, that cancels down even further. To just that. So, we now have x equals in a lot of cases, you're expected to show working out for some of these questions. Once you have this, though, once you have this at this point here, where it is in a numerical form. Because remember, what I'm going to be asking you is for exact numbers. And if you just use your CAS, you're most likely to get weird numbers that are decimals, etc. You're not actually giving me the working out that's going with it. Now that you've got this, though, I think you've done enough manual working out before you can plug it into your CAS. All right, I'm going to show you how to do that. But before we move on, if I have two different values for x, how many turning points am I actually going to be finding on the original graph? Because what is the original graph? What was the original graph? A cubic. And a cubic has how many turning points? It has 2. Unless it has an inflection point. So this means that I have 2 x values here, which means I need to find 2 turning points. If this was different and I only had one answer, then that means that I am looking for an inflection point instead. So now that I have this, which I can write as 2 plus minus root 19 over 3, I'm now going to go over to the CAS and break out the CAS, because putting that into a cubic is messy. I mean, if you want to do it by hand, by all means, but, you know, we've got a CAS, we might as well use the damn thing. So, hopefully this still works. I haven't used it since before the holidays. Alright. So I'm just going to shrink this down a little bit, put this over to the side, because I know we need it still, but I need a... Alright. Nope, don't want to do that. I do want to make this bigger though. So, we want to take our original graph. In fact, what we want to do is we might as well just use our original thing where it's not even factorized. Sorry, not even expanded. So, what we'll do is we'll define f of x as being x minus 3, x plus 2, x minus 1. Well, what is f of 2? Oh, well, first things first, keyboard, fraction 2 plus root 19 over 3. Can we get that? Will come out like that. What is that? In fact, that may actually be the simplest way of representing it using exact numbers. So, from here, we've got this answer here, which is going to be negative 4.06. we're then going to go back and do minus 8.202, so, or 208. So let's quickly just scribble those down as rough approximate. So we're going to have, what have I done? So I've got 8 0.208, and the other one was negative 4.06. So just for the record, this one was 2 minus root 19 over 3, and this one was 2 plus root 19 over 3. Just for the sake of argument. That's what it looks like expanded, by the way. So if you were to expand that and give it to me in its simplest possible, fully expanded form, that's what it looks like. Yeah, maybe not. So let's go into our graphing table and we will draw f of x. So there's f of x here. So if we find the maximum, negative 0.7863, which makes sense because it is negative, so it's 2 minus root 19. Root 19 is going to be about 4 and a bit, all divided by 3. Yep. Comes out at 8.208. Find our minimum, 2.11 or 2.12, and the answer is negative 4.06. So the answers that we've got for these exact numbers do make sense. So the next two, we are going to do just straight CAS. Okay? So, on your CAS, let's, we'll put that away for now, we don't need that. So, under Math 2, third row, second column, you'll find that button there. ddx, we want to do 4x. 4x3 minus 2x squared plus 9x minus 12. Gets us that answer there. Solve. Uh, 0 equals 12x squared minus 4x plus 9 comma x. So, it tells us no solution. It tells us no solution. So what does that mean for us? What does that mean for us? Because if we go and actually graph this, let's actually go and graph this cubic. 4x3 minus 2x squared plus 9x minus 12. It's clearly a cubic, yeah? Analysis, G-solve, inflection. It has an inflection point at 0.1666667. So that means it should have an intercept. So let's put that in there. 12x squared minus 4x how interesting. How interesting. Does anyone want to take a wild guess at where the turning point of the parabola is? I mean, sure, Desmos, but you don't get Desmos in a SAT or an exam, so CAS. We're going to stick with what we have access to. All right, so if we look at our CAS, analysis, and we want the minimum of this one here, look at where the minimum of that parabola is. Not the intercept, the minimum. So the graph is always, so a cubic like that, it has the same x value, not the same x intercept. It has the same x value as the inflection point. All right, so this one is sort of a tricky stump you question that I've sort of fallen backwards into. But the point is that you can use your knowledge of when you do come across this sort of situation. How do you find that? Well, you need to do what's called a double derivative. So don't stress too much if you couldn't get this one, because your CAS will do this one for you. This is the sort of question that I would give you straight away on the CAS, and you would have your CAS to do the entire thing. So again, to prove my point, analysis, G-solve, inflection on the blue line comes out at 0.1666666, etc. Negative 10.58. All right, so that's what your CAS would do. And now the last one. Go back to the menu. So we're going to define f of x as being x to the 4 plus 2x cubed minus 5x squared plus 8x minus 13. F of x, cool. Math to third row, second column. We want d dx of f of x. We get that. Solve 0 equals comma x. It gives us in exact form these lovely things. It only has one answer. Curious. Why is that curious? Remember, it's a quartic. All right. If we go and look at the quartic, again, we want to graph f of x. What does it have? What does it look like it has? It's a quartic. What does that graph have? What are the features of that graph? How many turning points does it have? Yeah, it has one turning point and one inflection point. So again, this is like the previous one. So it's got both a turning point and an inflection point, which means that when we graph, and remember what you can do with your CAS is in Y2, you can enter d dx f of x again. And you can find what we're looking for here. So, analysis, gsolve, inflection. I've tricked you again, it has 2 inflection points. This is what happens when we get to the higher order calculus stuff, is when we start working in, cubics, quartics, quintics, the properties of what you need to look for change. If you're working with a quartic, you need to care about the turning points and the intercepts of the one below. So, if you remember from the last question where the inflection point lined up with the turning point on the cubic derivative graph, where are the 2 inflection points on this graph going to be? All right, because what we've found is that it has 2 inflection points, not just 1. All right. So the intercept on the red graph, the actual x-intercept, is the turning point that is on our quartic, and the two turning points are going to line up with the inflection points on the blue graph. All right, so if I find the minimum and the maximum, see there, 540833 and negative 1.540833. All right, so you always have to make sure that you're aware of the fact that you might end up with more turning points than you were expecting. Because if you were to just look at that, I'd be like, oh yeah, sure, it has one. It might have one turning point and one inflection point. That makes sense. So just quickly, yeah, factorizes. It does factorize very messily. But that's what it factorizes to. All right. Home stretch. 3 more. These ones, nice and easy. I'm only looking for the general form. All right. Remember, you add 1 to the power, divide by the original power. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. At the end here, that's x to the 0, so I add 1, divide by 1, and then I have plus c on the end. So, on our CAS, we go 3rd row, 4th column. We leave the 2 boxes blank. We type in our equation, 8x cubed minus 9x right, thank you. Thank you for letting me know. So we go through here, 9x squared plus 2x minus 7 and dx. And I come out with this lovely thing here. But am I correct? Is this done? What has my CAS forgotten to put on the end? Oh, well, you can't see what's on the end because what has my CAS forgotten to put on the end? Whenever you're doing anti-differentiation, what should you always have on the end? Yep, plus C. Again, I haven't given you any extra information to find out what plus C is, but that's what you can do in the future. So again, same thing here. 12x squared minus 8x minus 12. Well, that 2 is going to become a 3, so therefore it's going to be 4x cubed minus 4x squared minus 12x plus c. And we'll see if I'm correct in a moment. Yep, 4x cubed minus 4x squared minus 12x plus c. And then last but not least, this bad boy here, 25x to the 4 is going to be 5x to the 5, 4x to the 4, 6x cubed minus 4x squared plus 9x plus c. 5x to the 5 plus 4x to the 4 minus 6x cubed minus 4x squared plus 9x plus c. Done, done, and done.